Have you ever wondered how data storage works in a Kubernetes environment? Well, today we're going to delve into that very topic. In the world of Kubernetes, data storage is absolutely essential. Whether we're talking about application logs, user data, or configuration files, Kubernetes needs a place to store and manage this data. That's where Kubernetes volumes come into play. Kubernetes volumes are a crucial component of Kubernetes architecture that serve a very specific purpose: to allow data to persist beyond the lifecycle of a pod. When a pod ceases to exist, the volume attached to it lives on. This persistent data storage is what makes Kubernetes so resilient and efficient. Volumes in Kubernetes aren't just about storage, though. They're about ensuring data is available when and where it's needed, and that it's safeguarded against loss. By the end of this tutorial, you will have a clear understanding of Kubernetes volumes and how to use them effectively. So, what exactly is a Kubernetes volume? Let's dive right into it. The concept of volumes in Kubernetes might seem a little daunting at first, but it's quite straightforward when you break it down. In essence, a volume in Kubernetes is a directory, possibly with some data in it, which is accessible to the containers in a pod. It's a mechanism for persisting data generated by and used by Docker containers. But unlike a Docker volume, a Kubernetes volume lives as long as the pod lives, not the container. If a container dies and gets restarted, the volume is still there, maintaining any data that was saved. This makes Kubernetes volumes a critical component for applications that need to maintain state or cache data. Now, there are different types of Kubernetes volumes, each with its own use case. Let's touch on a few of them. First up is empty dir. As the name suggests, it's initially empty. Containers in the pod can read from and write to the same empty dir volume, providing a simple way to share data between containers in a pod. Next, we have host path. This volume type mounts a file or directory from the host node's file system into your pod. It's useful when you want to use local storage or when you want to test a piece of software locally. Then there's persistent volume claim, or PVC for short. This is a request for storage by a user, somewhat similar to how pods consume node resources. It's a way to use durable storage that survives pod restarts. These are just a few examples of the many volume types that Kubernetes supports. Each one serves a unique purpose with its own pros and cons. So it's essential to understand them to make the right choice for your application's requirements. Now that you know what Kubernetes volumes are, let's move on to their implementation. How do we implement Kubernetes volumes into our environment? Well, let's dive right into it. The first thing we need to do is create a volume. This process begins by defining a volume in a Kubernetes pod. A Kubernetes volume lives as long as the pod that encloses it. So, even if a container within the pod crashes, the volume persists. This makes it an ideal solution for data that needs to survive container crashes. Now, how do we create this volume? Well, it's quite simple. In your pod specification, you define a volume of type empty dir. This creates an empty directory that can be read and written by containers in the pod. Once you've created your volume, the next step is to attach it to a pod. This is done by specifying the volume in the pod's specification file. You'll use the volumes field to define the volume and the volume mounts field to specify where in the container the volume should be mounted. Now you're probably wondering, how do I write data to this volume? Well, any data that your application writes to the mount path you specified will be stored in the volume. Remember, the data in the volume will persist even if the container crashes, but not if the pod does. So what happens if your pod crashes? Well, Kubernetes has a solution for that too. You can use a persistent volume, which is a piece of storage in the cluster that has been provisioned by an administrator. A persistent volume claim can then be used to request a specific size and access mode for that volume. And there you have it, a brief step-by-step guide on how to implement Kubernetes volumes. It's essential to remember that volumes play a critical role in data persistence in Kubernetes. They're the bridge that connects the ephemeral container world with the more persistent world of storage. With these steps, you can now implement Kubernetes volumes into your own environment. What are some common issues users face with Kubernetes volumes and how can we avoid them? Let's start with data loss. This is a nightmare scenario for any tech enthusiast. It often happens when a pod is deleted and with it any data written to the container's file system. To avoid this, it's vital to use Kubernetes persistent volumes. These are designed to survive pod deletion and keep your data safe and sound. Next up, volume mounting failures. These can happen for a variety of reasons, such as network hiccups, cloud provider issues, or simply incorrect configuration. To prevent these, ensure that your volume exists and is accessible before trying to mount it. Also, double-check your configuration files for any errors. Remember, Kubernetes can't mount what it can't find. Then, there are permission errors. These usually occur when the Kubernetes process doesn't have the right to read or write to the volume. To avoid this, make sure that the user running the Kubernetes process has the appropriate permissions for the volume. It's a simple fix, but one that's often overlooked. Another common issue is running out of storage space. Kubernetes volumes aren't infinitely expandable. If you're frequently running out of space, consider implementing resource quotas and limits. This can help you manage your storage more effectively and prevent any unpleasant surprises. Finally, let's talk about data corruption. This can occur when multiple pods write to the same volume simultaneously. The solution? Use read-write-once access mode. This ensures that the volume can be mounted as read-write by a single node only, preventing any potential data corruption. In summary, managing volumes in Kubernetes can be tricky, but with the right knowledge and precaution, you can avoid most pitfalls. Implement persistent volumes to prevent data loss. Ensure your volumes are accessible and correctly configured to avoid mounting failures. Grant the appropriate permissions to avoid permission errors. Manage your storage effectively to avoid running out of space, and use read-write-once access mode to prevent data corruption. By being aware of these common pitfalls, you can ensure a smoother operation of your Kubernetes volumes. What are some tips and tricks for managing Kubernetes volumes effectively? Let's dive right in. First up, labeling. Labels are a tool that Kubernetes provides to help you organize your resources. By applying descriptive labels to your volumes, you can streamline your management tasks and make it easier to identify specific volumes when needed. For example, you could use labels to indicate the purpose of a volume, the project it's associated with, or any other relevant information. This can be a real time saver when you're dealing with a large number of volumes. Next, let's talk about access controls. Access controls are critical for ensuring the security of your data. Kubernetes provides a variety of ways to control access to volumes, including role-based access control, or RBAC for short. With RBAC, you can define roles with specific permissions and assign them to users or groups. This allows you to restrict who can access a volume and what they can do with it, helping to prevent unauthorized access or misuse of data. Monitoring volume usage is another key aspect of managing Kubernetes volumes. This includes keeping an eye on how much storage space is being used, as well as monitoring for any performance issues. Kubernetes provides tools for monitoring volume usage, but there are also third-party tools available that can offer more advanced features. Regular monitoring can help you catch any issues early and prevent them from escalating into bigger problems. Also, consider setting up alerts for important events or conditions. For instance, you might want to receive an alert if a volume is nearing its capacity, or if there's a sudden spike in read or write operations. This can help you stay on top of things and take action before a situation becomes critical. Last but not least, remember to always have a backup plan. Even with the best management practices, things can go wrong. Regularly backing up your volumes can save you from a lot of headaches down the line. It's also a good idea to test your backups periodically to ensure they're working as expected. With these tips and tricks, managing your Kubernetes volumes will be a breeze. Let's recap what we've learned about Kubernetes volumes. Kubernetes volumes are a critical component of any Kubernetes environment. They provide persistent storage to containers, ensuring that data is not lost when a container crashes or is terminated. We've also delved into the implementation of Kubernetes volumes. We learned that You can create a volume in a pod and then mount that volume into a container within that pod. This process ensures your data is accessible and safe. We addressed common pitfalls, such as not correctly configuring your volumes, which can result in data loss. We outlined the importance of thoroughly understanding your configuration and ensuring it matches your specific needs. We shared some useful tips and tricks for managing your Kubernetes volumes, like using volume plugins for specific storage systems and regularly monitoring your volumes. And that wraps up our tutorial on Kubernetes volumes. Remember, understanding and effectively managing your Kubernetes volumes is crucial to the efficient